Hello, hi all. This is Mohammed Abdulkhair and welcome to AppSec Untangled. So today we're going to be talking about AI agents. AI agents have unlocked many new use cases, made a lot of new automations possible by connecting the power of AI to data and actions to basically perform these things on behalf of the user. Uh, this made a lot of new things possible, but at the same time, like any new technology, it introduced new risks. And today we're going to be discussing one of these new risks, which is an old security problem called the confused deputy. We're going to discuss that in more detail and see how relevant it is to AI agents. In other words, also this could be described as how the capabilities of AI agents are being abused or could be abused. So we're going to see how this works in real world, see some examples, and we're going to also discuss the mitigations for it. So let's get to the details. Okay, so let's start with a very quick definition of what an AI agent is. It's basically a system that has access to an AI service, an LLM, and at the same time uses tools or capabilities to be able to read data on behalf of the user or perform actions on behalf of the user. For example, like have some API keys to perform actions on a service that this user has access to, and so on. So basically, this is what we are going to be considering an AI agent, and we're going to see how the security problem we are going to be discussing today is relevant to it. But before we do that, let's discuss the security problem itself. The confused deputy problem to be specific. And like I said, this is an old security problem. So let's first understand what it is and see an example of how it works in like non-AI classic applications. And then we're going to see how this applies to AI agents. Um, so basically a confused deputy situation or like a system that has the confused deputy problem is basically when you have a user dealing with, let's say, a specific service or system, and this user doesn't have a specific permission to read a specific set of data or to perform an action in that service. But this user has access to another, let's call it intermediate service. Okay. And this service does have that permission. So this service can perform that action in the original service. So the user basically tricks or confuses that intermediate service to perform that action on his behalf. So now he is able to perform this unauthorized action. So you can think of it, let's take a web application where you, as a user, can not, let's say, for example, promote a user to an admin, but maybe using the API of that same web application, you can do so. So this is a confused deputy problem because now you are bypassing authorization. So this is basically the design issue leading you to bypass authorization in this case. And let's take one example of this. So this is something that affected multiple AWS services, a confused deputy problem. One of these AWS services that was affected is the CloudTrail service in this case. So CloudTrail is a service that generates audit logs. It sees what's happening in your AWS account and generate audit logs and write these things to a bucket. To be able to write these things to your bucket, obviously, the service principal of CloudTrail needs to have write access to your bucket. Okay. Uh, but the same thing is that it has access to your bucket and any other customer that has CloudTrail enabled as well. So what was happening here is an attacker can go configure CloudTrail in the attacker's account, but give the name of a bucket in the victim's account, so in another account. And because while the attacker doesn't have access to the bucket in the victim's account, the Cloud Trail principal does have that access. So I can give CloudTrail a bucket in another account, and it will go write my own CloudTrail logs to that other account. So in this case, the CloudTrail service principal is the confused deputy, and the abused capability is writing to the victim's bucket. And obviously, the impact here is just like you are able to write your bucket, so you could maybe inflict extra costs or whatever, just like cause some sort of inconvenience to the owner of that bucket. So that was basically the impact of it in this case. And many other services had that same pattern. And then AWS had a whole like blog about it, and you can even see it here, and you'll see like a lot of uh, that's not it. Um, yeah, so that's like in AWS documentation. You can read all about it here, and you'll see even some of the mitigations where basically you could, in the bucket policy, while allowing the action itself, you could also add an extra condition about the source account of these things. So like that was basically this source account thing was the mitigation here. Now, obviously, this is uh, not our concern, but the point is this is a good example of what a confused deputy problem is. Now, let's get back to how this relates to an AI agent, uh, because we talked about an AI agent having permissions and capabilities before. So, if you think about it, if someone is able to trick that AI agent into abusing these permissions, while this user doesn't have these permissions themselves, then AI agents is also going to be in a confused deputy situation. Now, before we get to the details, there is one thing I want to maybe iterate on or discuss here, which is the difference between how this works in a classic non-AI system and for AI agents. Because let's take the CloudTrail example. So in the CloudTrail example, for confused deputy to be possible, there were two things that needed to be there, and these two things needed to be connected. So the first thing is an entry point. So this is some kind of user input and one of the permissions of the system. So in this case, the user input was the bucket ARN, which was the bucket in the victim's account, and the permission or the capability was writing to the bucket. So these two things were connected in the logic of the system itself. Okay, and obviously the CloudTrail service had many other permissions and many other user inputs, but because they were not connected into this logic, we didn't have any other confused deputy situations. So we needed to have this hard coded logic connection between a user input and a permission. Now, if you compare that to AI agents, it's gonna be much more fluid because AI agents don't have hard coded logic. They work every time differently. They are not deterministic. They can do whatever they are told with the permissions they have. And as we're going to see also that the user inputs come in from many different places. So the connections between user inputs and permissions, as we are going to see, are going to be much more fluid, and hence the possibility of creating confused deputy relations between inputs and permissions are going to be much more likely and much more impactful. And we're going to see that in the examples as we get to it. So this is one thing that is different between AI agents and like classic non-AI systems. And that's one of the reasons why confused deputy is a bigger problem for AI agents. Okay, so let's get to some examples of how this works. And let's create a sample application. Okay, and just this is just like a sample application. I have it on um, like this open source repo here. So this is called Snippets AI. Okay, and this is a way for users to share their snippets. Again, this is like a sample application I created. So just to show how this would work. So as a user, I can go register to this application, log in, and then create code snippets. And the thing is, code snippets could be public or could be private. So I can create my private code snippets and use them myself, or I can make them public for other people to use. I'm sure you have seen other similar services before, and I can list this. So this is the service itself. Now, let's say we wanted to add a feature to it, which is an AI search feature. So I can go here and just give a query, like give me the code snippet that prints hello world in Python, whatever, and just like give me the results. So now this will give me the code snippet that's most relevant to what I want. So just like utility specific use case or a specific function, and it will just look in all of the code snippets and give me the one that is most relevant to my question. So a very like useful use case, but we're gonna see how this could be abused in a moment. So let's start this application. I'm just gonna go here. I already have it cloned and ready to run. So I'm just gonna run it right now. Okay, so let me just register as, I'm just gonna create get a CSRF token because this is needed. So we have a /CSRF token. And before even using it, let's quickly have a look at the code so that we understand what we're doing. So basically, that's the application itself. So this is an Express application, and obviously it uses like, it has like an authenticate. So it's using Express session, so like session cookie for authentication. We have a CSRF token, so just like basic stuff, and then we have a register route to create a new user. We're using Mongo, by the way, in the backend. We have route to login, route to logout, and then like this is to a post /snippets to create routes, list routes with get, and then obviously update and delete. So basic root stuff. And then this is the one obviously that you basically is using the AI agent in the background, this AI search new route. And this is the AI agent. This just like takes a prompt. So this is a prompt. You're a helpful code assistant. Search through these code snippets and return this. And just like it takes, basically it lists the code snippets, adds them here, and it adds the query, and then it gives back like the result. So again, just like very simple AI client in this case that has like a built-in prompt. So like a very simple AI agent. Okay, so this is how it works, and we have it running. So let's get back here and start. I'm just going to be copying the commands from the README file, so you can find it here, like all of the commands to register, login, list, create, and so on. So I'm just going to copy and paste these things. So I'm going to register a new user. Okay, so this is the /register route, user one. Okay, so now I'm going to log in. Okay, so now I have logged in, and now I have stored my credentials in this cookies.txt file. Okay, so now I can create a public code snippet. So this is a code snippet. I just like print hello world. So obviously very simple. And then we can do another one that is private. So I'm going to do this other one. So this has console.log super secret code, and this access level is set to private. Okay. So now if my user one, lists all of the snippets, so I'm going to see all of these. Oh, actually I did it before. So I have like these two. So we have like hello world, this is public, and this super secret example is private. Okay. So now let's go and create a different user. I'm just also gonna get this token here and register this user. And now let's call that the attacker. Okay, I think I already have this. I'm just gonna log in with it. Okay, so now we are logged in as the attacker. And now if we try to list this, so we should only, are we logged in? I think we logged in as user one. So let's log in back as the attacker. So I'm just gonna do that. Okay, So let's log in as attacker. Okay, now we are logged in as attacker. And now let's go and try and list the code snippets as attacker. So now we cannot see the private ones because they belong to the other user, but we can see the public ones. Okay. Now let's talk how we can abuse this. We go back to the code here. What's happening in the AI agent is that we are basically getting all of the snippets and we are just adding them to the query. So while me as a user don't have access to all of the snippets, I only have access to the public ones or the ones that I own. The agent has access to all of the queries, so all of the snippets. So it can see all of the snippets and it passes them to the prompt. So what I can do here is try something like this. So let's first see how it works. So the AI search feature. So let's start with this. So if I go back to, let's see first how it works and then how it can be abused. So now this is user one. If I go and tell it this is the AI search route, it'll just give me the code snippets to print the hello world thing. So it's just going to look into everything. And now it's sending these things to AI, build the prompt, send it to AI. And it tells me, okay, this is the one that is most relevant to your question. Okay. Now let's try this one. And again, this is the attacker. So this doesn't have access to the private ones. So if I do this and just like say, give me the super secret code. So now I'm just giving it this query and running it. So now it gave me these two private snippets that I don't have access to. If I list, I don't see them here, but my query told the agent to show them to me. So now they are here. So this is me abusing the AI agent to get access to snippets that are private and I don't have access to. So in this case, the AI agent is acting as the confused deputy and is giving me access to something that I don't directly have access to, but I can, through the AI agent, get access to it. And this is a design problem because the agent has access to things that I don't have access to. And we're going to discuss how to mitigate that by the end of the session. But I hope this makes it clear how this works in real life. Okay, so okay, so let's get back to our slides. Okay, so again, in this case, the AI search agent is the confused deputy because I don't have direct access to the private snippets, but the AI search agent has, and I just was able to trick it to get access to this. So let's get some other more real world examples. So, for example, this is something that many enterprises are trying to do right now, having an AI search feature where you connect your agent to some of your internal stuff, Slack, Google Drive, like whatever service you have. You want to do a search, but on some of your internal content. And very similarly to the Snippets AI feature, obviously these things. So, for example, in Slack, you would have some public channels, but also you'd have some private channels. And what would end up happening here is me as a user may not have access to a private channel, but let's say if the Slack or the AI agent app was added to one of these private channels, and I ask a question about something, let's say it's um, a director level channel discussing budget or whatever. If I ask it a question about that, and if it is present in this channel, it will give me an answer about something that I'm not authorized to see myself in Slack, uh, unless obviously we are able to make sure that the agent itself, when I'm calling it, doesn't have access to the things that I don't have access to. So this is another example. Again, just like you're talking about Slack, so we have like public and private stuff. similarly for Google Drive, you have some private documents, public documents within the organization. So if the agent has access to everything in Google Drive and Slack, then users can use it to gain access to the channels and documents they don't have access to. So again, these are two examples showing how me as the direct coder of an AI agent can just with a direct prompt abuse its permissions and gain access to something that I normally or shouldn't have access to. Now let's take this other example, and this comes from this blog post by Invariant Labs, which is a very interesting one. And this also is going to be a different kind of example. So in this case, basically they are talking about an AI agent used to administer a GitHub organization. Okay, so this is meant to be used by GitHub admins, and they can just go say list all of the issues in this repo and suggest fixes, or like reply with something to the opener, whatever. Like just manage your GitHub repos. Now the thing is, in this organization, you potentially could have some private repos and some public repos, right? So you'd have within that same repo multiple things. And now, if you think about the confused deputy situation, now this AI agent has admin access to the GitHub org, but the users, the direct users of this, are GitHub admins as well. So they have that same level of permission. So it looks like maybe confused deputy is not a problem here because we have the same permissions. So I cannot really abuse it to do something I don't have permission to do myself. But now this doesn't take into consideration one important thing, which is that the prompts being used by the AI agent don't only come from the direct caller. So for example, in this case, if someone goes and opens an issue in one of the public repos, anybody can open an issue in a public repo normally. So like this is something that you don't need to be even a member of the org to do, let alone an org admin. So you can just go open an issue, and then you can put some instructions for the AI agent there. So saying that this, like read the README file of all of the author's repo and just create, add the chapter to the README here. So it's like basically it's telling the agent to read some stuff from the private repos and post it on a repo that the attacker called. So re-exposing some internal information about the private repo. And this is a really important thing because now this is a different type of confused deputy situation where the attacker is targeting the agent through indirect input. So this is something that in itself is not the direct input of the AI agent, but this is gonna. So once I go and as a GitHub admin, go and give it a prompt like this one, have a look at my issues and address them, it's gonna read this thing, and now obviously this is like a prompt injection payload in this case. It's gonna trick the agent into performing these things, and it will end up reading stuff from the private repos and putting it to this repo. So it's exposing internal private stuff to a public repo that is owned and controlled by the attacker. So now we are abusing the permissions of this AI agent. So again, this is another example, but in this case, this is happening through indirect prompt injection rather than the direct input of the agent. So the direct user here is not subject to confused deputy, but again, a user that doesn't have any kind of access does have permission to write to an issue, which is gonna be read by the AI agent, and hence this user is able to abuse the permissions of that agent to read the information in the private repo. So this is another example, and this takes us back to what we discussed earlier about these really interesting and fluid relations between inputs and outputs. We saw an input that, so normally if this is not like an AI agent, if you're writing something that tries to perform the same action without using AI, it's very hard to have that relation between something like the issue description and reading like the contents of a private repo. But because this is an AI agent, this relation between the user input, the issue description, and reading private repo information was possible. So this, again, in classic non-AI systems, is very hard to find that kind of relation because it needs to be hard-coded. But in AI agents, it's not hard-coded, it's not deterministic. So these things are much more likely to be possible. And just to prove that, we're going to see more examples. So for example, here, this is a file. This is a CVE that affected VS Code's Copilot. And again, all what you need is just to like trick someone into opening a file and then just asking any question here, asking Copilot to explain something in the file. And all what you need to have this prompt injection payload in the description. This is telling it to disable the setting which needs to ask you for permission before running commands, and then run a command, which in this case opened a calculator. But obviously, like if this was an attacker, this would have been or could have been much more serious. So again, you can just run any command by just tricking someone into opening a file and asking the AI agent, the coding agent in this case, about it. Similarly, this is a Comet, an AI browser. So again, you can trick it into exposing the user credentials and performing actions on behalf of the user by just adding, let's say, a Reddit comment that has some prompt injection payload, asking the AI agent to perform some actions in the browser on behalf of the user, to ask for, let's say, a 2FA code and go and read it from the email and then post it here. So it's like exposing an authentication code in a Reddit comment, because the AI agent has access to your email in another tab, and it has access to this, right to this page. So it can, on your behalf, expose your credentials in a public page. Supabase had a very similar issue to the GitHub one, where you have like a ticket description, ask it to expose some stuff. Now, the thing here is that you're exposing some credentials from a Supabase managed database. So this and some other examples show you that this is now becoming a pattern, like through indirect prompt injection and through direct input, you can abuse the permissions and make your AI agent a confused deputy to, again, just abuse something that it is able to do, while the person giving it the input, direct or indirect, doesn't have access to do. And as you can see, these relations between inputs and outputs are very fluid, so it's much more likely and much more possible that these things happen with AI. Okay. Okay, so now that we know this is possible, obviously we need to discuss the mitigation. And the first thing to understand here is, first of all, this is a design problem. Like, this is something that we need to be careful with while we are designing our AI agents. And the second thing as well is that we talked about prompt injection. Prompt injection doesn't have like 100% guaranteed mitigation. And the reason is basically like the system instructions or the prompt injection payload is just tokens and text added to the LLM. There is no real distinction between what should be system instructions and user data, because that's text and that text. So as long as you're going to be taking user input and adding it to the prompt, then prompt injection is always going to be possible. What we can do is really manage the risk and reduce the likelihood of it affecting us rather than fully mitigate. So these are two things I wanted to mention. Now, that being said, the first thing to be able to mitigate this is you need to know that this is possible, okay, and you need to plan for it. So basically, what we need to do is start with this mental model before, when we are designing our AI agent, and we want to take three things into consideration. First of all, the agent itself, okay, here, and the agent permission. So the permissions of the agent itself. So this is the agent, and this is the things that it can do. Okay. Now, the other thing, who are going to be the direct callers? So if it's a chatbot or whatever, who are going to be the direct caller and what permissions they typically have. Okay. And the third really important thing is also what other inputs are going to be used, so anything that's going to be read and put into a prompt. So we saw the GitHub issue description, the Supabase ticket description, the file comments, the web page. All of these are things that are going to be used. So all of these things that are potentially, all of the user inputs that are potentially going to be added to a prompt and sent to the LLM, and who has access to these things. So these are three things. So the permissions of the agent itself, the permissions of the direct caller, the inputs, and the permissions of the users that can create or modify these inputs. Okay. And we want to compare these things. If, for example, there are some capabilities that the agent has, but the direct caller doesn't have, then confused deputy is possible, and we need to find a mitigation for it. If there are permissions that the agent has and some of the people that are able to create or modify indirect inputs don't have, then also it's possible, and we need to find mitigation for it. But if not, then let's say if this agent only searches the web and give like for public articles and summarizes this, then like confused deputy obviously doesn't become relevant, because now like the permissions of the agent um, doesn't include anything that the direct or the indirect callers don't have. So we use this mental model to decide whether it's relevant, and if it is relevant, we're gonna then discuss some other things we need to do. Now let's start with the basics. Obviously, least privilege is a very good place to start. It's a basic security principle. Permissions that you do not have cannot be abused. So don't give the agent any permissions that it doesn't need. Now, to be able to do that, this takes us to limiting the scope of the agent. Don't create very powerful agents that can do everything that you want to be done, because then you wouldn't be able to have least privilege. Minimize the goal and the tasks that the agent is able to do, so that you can minimize the permission. So always think about uh, the specific goal of that agent and just give it the exact same permissions it needs. If you don't start with a clear goal, you will have too wide of permissions. Uh, and then obviously giving the agent the same permissions as the caller is a really good strategy. This eliminates the direct path of the confused deputy problem. So if the agent only has a subset of the permissions of the direct caller, then confused deputy gets eliminated. So this includes, for example, if you're using MCP, use OAuth with the MCP so that you get a user scoped token. So for example, this eliminates, we talked about like using like an AI search with Slack, Google Drive, and so on. So if you use OAuth with that, and you just get a token that is user scoped, then you will only have access to the Slack channels that the user has access to, and the agent is going to use that token, user scope token. So that's one way to do it. Or if we go back to the SnippetsAI example, so if we the problem here is the agent had access to snippets that the caller didn't have access to. So we can easily fix that by just changing this one line. We can get to it here. So instead of like doing this like snippets find all here, we change it to finding the ones that the caller. So we give this agent the caller ID or the user ID as input, and we tell it only get the ones that are public or the ones that are owned by this user. So this is a way that this agent now will only have access to the same snippets the caller has access to. So now it cannot be abused. So this eliminates, again, the direct caller confused deputy problem in this case if we do it this way. Okay. Now, the other thing about indirect, always try and enumerate all of the inputs that are potentially going to be ending up in prompts. So find all of the entry points, all of the user inputs, all of the indirect places where we are going to be reading something and adding it to prompt. And always remember that prompt injection cannot be fully prevented, but its impact can be minimized. Now, obviously, you're going to end up in some situations where you have an AI agent and it needs to read something like the GitHub issue description that is publicly writable. So if the agent needs to do something, then you'll need to think about some strategies to apply some guardrails. And probably in an upcoming video, we're going to discuss that in more detail. But just try to think about how, in these cases, you can limit the blast radius or the impact of any prompt injection payload. So, for example, like this is a guardrail that says, okay, we are going to be reading stuff from public repos. So we are going to limit the impact of that by saying that within this session, if you once you start reading something from a repo, although you have access to all of the repos within this session, you will only have access, or you can only access this one repo. So just make sure that the call before and the call after is the same repo and the same owner. So this limits the session to one repo rather than all of the repos, and hence limits the impact that we talked about, where you start with a public repo and you use that to access a private repo. This is one way to do it. And this is an example of our guardrail that does that for you. This MCP gateway is another tool, by the way, that can be used for that same thing as well. So you can explore that. And again, just this is saying cross repo access. So this is like just adds it as an MCP gateway, like between your AI agent and the MCP. And also, again, it checks like the target repo before and after. And if it's different repo, it just says cross repo access is prevented, and so on. And again, obviously, sometimes for some other impacts, like for example, like trying to access, like to steal the prompt or whatever, you need to add maybe a guardrail that, for example, just takes that user input and passes it to another AI agent, which just checks whether this input has this like prompt injection or not. Again, not 100% guaranteed, but makes things much better as well. And again, like I said, in a future session, we can explore that in much more detail. Lastly, if you have any dangerous actions, adding human in the loop is a good strategy. I would just say here, don't overdo it, because if you just keep asking the user a lot of times, users tend to just like accept by default. So use that wisely, but just add it for the most important and dangerous actions. So this is basically what I wanted to discuss here. To recap, we went through the confused data problem and how it is relevant to AI agents, and why it's much more likely and much more impactful because of this fluid relation between the inputs and capabilities. And we saw some examples, a sample code, and we saw some real world examples as well of AI agents that were vulnerable to different types of prompt injection. And we discussed how this is a design problem, so this needs to be mitigated by proper design, having this mental model about the direct callers, the indirect inputs, and the prompt and the AI agent capabilities, and comparing these things, and then using the right least privilege principle, limiting the scope, having the subset of same or subset of the users of the caller's permissions, and adding guardrails and human in the loop as mitigations. So I hope you found this useful, and looking forward to see you in the next one. Have a great day.